Good morning, dear students. In the last class, we had a discussion on Newton's law of gravitation, where we talked about the mathematical statement. We derived the formula F is equal to G m1 m2 by r square. We defined G, then we solved a few numericals related to F is equal to G m1 m2 by r square. I also gave you a homework. The question was to find out the attraction between force of attraction between Earth and the Moon. Mass of Earth, this is 6 into 10 power of 24 kg, and mass of Moon, it is I think given in your book. The mass of Moon is how much? 7.4 into 10 power of 22 kg. The distance between the Earth and the Moon is given as, this is the value of R. R is given 3.84 into 10 power of 5 kilometer. So most of you must have done this. Let us try to do it again, and then we will move on to the next topic. So the formula for force is F is equal to G m1 n2 by r square. The value of G is 6.7 into 10 power of minus 11. Mass of the Earth is given 6 into 10 power of 24. Then mass of Moon is 7.4 into 10 power of 22 kg. Divided by, now look at the value of R. It is 3.84 into 10 power of 5 kilometers. So if you convert this into meter, this would be 3.84 into 10 power of 8 meters. So let us put the value here, 3.84 into 10 power of 8 whole square. So let us solve this further. This would give you, to solve it, 6.7 into 6 into 7.4 divided by 3.84 into 3.84 multiply by 10 power of minus 11 plus 24 plus 22 minus 16, because 8 square is 16, so 10 power of minus 16. So when it goes to the numerator, 16 becomes minus 16. Now if you solve this further, now last time I told you about approximation, how to cancel these values. Let us first solve this part. 10 power of minus 11 plus 24, so it is 13. 13 and 22 gives 35. 35 minus 16 is 10 power of 19. So this would be in Newton. Now let us try to solve this part. Now if you look at the denominator 3.8, so this 3.8 Double 3.8 is 7.6. So I can cancel this with 2 times, nearly 2 times. So 3.8 into 2 is 7.6. We are having 7.4 in the numerator. So it is 2 times. Similarly, this is 3.84. I can write this 3.84 as approximately equal to 4. So this can be written as 6.7 into 6 into 2 divided by, I can write this as 4. So it is 2 into 2 is 4. This is 2 into 3, 6. So if you solve it now, you will get 6.7 into 3 multiply 10 power of 19 Newton. So this makes the calculation very easy now. So 7 3 is 21, 2, so it is 20.1 into 10 power of 19, or you get 2.01 into 10 power of 20 Newton. This would be the answer which you must have got to this question. So the given answer is 2.02 into 10 power of 20 Newton. We have got approximately very close to that value. So it is 2.01 in 10 power of 20 Newton. Now, let us move further with the syllabus. Let us talk about a new topic today, that is free fall. Now, if you look at this word free fall, what is the meaning of free fall? Anything which is falling freely means, if you simply write anything falling freely. Now, if you talk about the Earth system, we have got the Earth. Let us say this is the Earth, and we have an object at a height h. If the small object is released from that height h, what would happen when the small object is released, or we can say dropped from a certain height, the body would fall down under the influence of gravity or gravitational force. So if a body is falling freely downwards only under the influence of gravity, then we say that the body has got a free fall. So the definition of this would be, if a body if a body falls only under the influence of gravitational force, only under the influence of gravitational force, the body is said to have a free fall. So anything which is falling downwards under gravity has got a free fall. And when it is falling freely downwards, it is coming with an acceleration. The acceleration, we have already talked about acceleration due to gravity in chapter number 1. Acceleration due to gravity acceleration due to gravity is equal to g and this is equal to 9.8 meter per second square for Earth. For Earth, it is 9.8 meter per second square. In the uh, other topics, when we talk about Moon, we would be talking about acceleration due to gravity on Moon. G on Moon is equal to 9.8 by 6. It is 1/6 the value of Earth. It is about 1.63 meter per second square. We would be talking about this in the other lectures. So today let us try to find out a mathematical expression for free fall. So let us write the next topic. It is mathematical expression for free fall. So to derive the expression, let us consider the Earth and a small object. Let us take the Earth. Let us say this is the Earth, and we have got a small object. Let us say here, and this is at a height of h from the ground. So let us write down the conditions. Consider a small object of mass m at an at a height of h from the surface of Earth. So this object has got a mass m. Earth, let m be the let capital M. Let us take, let m, capital M, is equal to mass of Earth, and r is equal to the radius of Earth. Now if you look at this diagram, Earth is a huge object in comparison to this object. So Earth is pulling this object downwards with some force. So we can calculate the force. Now this is the radius r. You can draw a better diagram. So if we calculate the force of attraction between the Earth and the object, we can use the Newton's law of gravitation. So force of attraction between Earth and the object is equal to F, and this can be written as G into mass of Earth multiply mass of object divided by distance whole square. So we have got F is equal to G, mass of Earth we have taken as capital M, mass of object is small m, and distance is r is the radius of Earth, and h is the height from the surface of Earth whole square. Now if you look at the diagram, h is very small as compared to the radius of Earth, as h is very small as compared to the radius of Earth. Now, what is the value of R? R is 6,400 kilometer. And we are talking about some height h above the ground. So h is very, very small. Means h very, very small as compared to R. So R plus h whole square can be written as R square. So what the equation changes into F is equal to G capital M small m by R square. Let us say this is equation number 1. This is the force we have calculated by using the equation of gravitation, Newton's law of gravitation. Now, if you talk about chapter number 2, force and laws of motion, we have already talked about force is equal to mass into acceleration. If small g is equal to acceleration due to gravity, if small g is equal to acceleration due to gravity, with which the object is falling towards the earth, is falling towards the earth, then we can write then force of attraction is equal to mass into acceleration. This we are getting, actually we are using this Newton's second law of motion, F is equal to m into a, which you have already learned in chapter number 2. So we can write F is equal to m into g, because we have taken g as the acceleration due to gravity. Let us say this is equation number 2, and we have already got equation number 1. F is equal to g m1 g capital M small m by r square. The second equation is F is equal to small m into small g. So from 1 and 2, from 1 and 2, we get g capital M small m by r square is equal to m into g. So m and small m gets cancelled. So ultimately we get small g is equal to acceleration due to gravity and this is equal to capital G capital M by r square. Capital G is a constant, capital M is the mass of Earth, capital R is the radius of Earth. So from this equation, we come to a very important conclusion that acceleration due to gravity depends on the mass of the planet and the radius of the planet. Small g depends on capital M, means mass of the planet, and capital R, that is radius of the planet. Small g is not at all depending on the mass of the body. So we can write acceleration due to gravity. Acceleration due to gravity is independent of mass of object. Means if you go to a high rise building, let us say we have got a tower, Let us say this is the tower, and you drop a small stone, you drop a huge stone. Let us say this is M1 and this is M2, and M1 is greater than M2. As we have discussed now, that acceleration due to gravity is independent of the mass of object. So the question is, what do you think? Which object is going to reach the ground first? If the question is, out of M1 and M2, which object reaches the ground first? So the answer would be both reach the ground at the same time. We are ignoring the air resistance here. If you ignore the air resistance, both M1 and M2, because they are falling under gravity, both M1 and M2 would have the same acceleration due to gravity. Both M1 and M2 would have the same acceleration, that is somewhere very close to 9.8 meter per second square. And therefore, what would happen? Both the stones would reach the ground exactly at the same time. So this is what is called free fall. So during free fall, the acceleration of the body is 9.8 meter per second square. Now we have got a formula. G is equal to small g is equal to capital G capital M by R square. Now capital G, the value is 6.7 into 10 power of minus 11 Newton meter square per kg square. And mass of earth, we already know the value is 6 into 10 power of 24 kg. And radius of earth is equal to 6,400 kilometer. Now if you use these three values, then you would get the acceleration due to gravity of earth is equal to 9.8 meter per second square. Now this you can try at home. You can put the values and calculate it yourself. I'm just writing down the values here. Okay. And what is the direction of acceleration due to gravity? The direction of G, very important concepts. You just have to remember this. The direction of acceleration due to gravity, the direction of acceleration due to gravity is towards the center of the earth. It is always directed towards the center of earth. And at the center, another very important thing, at the center of earth, at the center of earth, the value of small g is equal to 0. At the center it is always 0. Okay. Now we have already talked about acceleration due to gravity, it is independent of the mass of object. Now about the shape of the earth. What is the shape of earth? Earth is not a perfect sphere. It is not a perfect sphere. It is flat from the top. So if you draw the diagram of the earth, it would be something like this. Something like this. If it is flat from the top, means if I take this as the radius from the equator side, this is the equatorial side, and this is the pole side. I take R E as the radius in the equatorial plane. R E is the radius of Earth along the equator, and let us say this is RP. RP is equal to radius of Earth along the pole. And because it is not a perfect sphere, we would have RE greater than RP. Radius at the equator is always greater than the radius at the poles. So this distance, this radius is the equatorial radius, and we have got the polar radius. This is the polar radius. And RP is less and R equator is greater. So according to the formula of acceleration due to gravity, G is equal to capital Gm by R square. Now, from this equation, we have acceleration due to gravity is inversely proportional to the square of radius. Means, more is the radius, more is the radius of Earth, more is the radius of Earth, lesser would be the value of G. Lesser would be the value of small g. So acceleration due to gravity. Now as R equator is greater than R pole, so we can write a conclusion that G at equator will always be less than G at pole. So if you move from the pole to the equator of Earth, if you are moving along, if you are moving from the pole towards the equator, you are coming to a place where the acceleration is reducing because RE is greater than RP. So acceleration due to gravity at the equator, acceleration due to gravity at equator is always lesser than acceleration due to gravity at the poles. So, what did we discuss today? We talked about free fall, We talked about free fall, then we talked about the mathematical derivation, how to calculate the acceleration due to gravity during free fall, and then we discussed about variation. This is actually what we are talking about in this topic. This is variation of G. This is variation of G at equator and the pole. So revise these topics which we have learned today and prepare well. We will be doing or we will be solving more numericals related to these topics in the next lecture. Thank you very much.